All right, so now continuation, we'll be looking at the determinant for n by n matrix for any n. As long as n is greater than equals to 3, we can use this method. So, but first we need to define what we call a minor and cofactor. So if you have any matrix A, which is an n by n matrix, the minor, which you call Mij of the element, is simply the determinant of the matrix obtained by deleting the ith row and the jth column, right? So, if you want to find the cofactor, it's just Aij is simply minus I plus j of the Mij. So let's just illustrate this with an example. It's this is matrix A. Now we can find a lot of things. What can we find here? So for example, if this is A, we can ask to find the minor, let's say M13. If you want to find M13, what does that mean? It means you delete the first row and the third column. So what is the first row and the third column? This is it. So you can see we are left with what? With a 2 by 2 matrix. So Mij is just the determinant of the 2 by 2 matrix that is remaining. And this will be 0. So you have 0 minus 4. So it means Mij is just equals to 4, which is the minor. Now, if you want to find a cofactor, which is A13, by the formula, is just minus 1. Then I is 1, J is 3. Then you have M13. So we're applying this formula. So each entry has a minor. Each entry has a what? Cofactor. And this will simply be what? Minus 1 to power 4 multiplied by 4, which is already our M13. And this means that you are still going to get 4. So in this case, you see that the M13 and A13, they are the same. Right. Okay. So this is just what we're calculating here. But let's see if we take another one. Let's say we find, let's now calculate M23. If you want to find M23, delete the second row and delete the what? The third column. And this will give us what? This will give us determinant of 2, 3, minus 2, and 5. And this will be 10 minus 6. And this is going to give us what? 16. Correct? Yes. So, but what is A23, which is the cofactor, is going to be minus 1, 2 plus 3, M23. This is just going to be minus 1 multiplied by 16. So this is going to be minus 16. All right. So this is how to find the minor and the what? And the cofactor. All right. So let's see how that affects. So actually, if you look at every element, just like I said, you can find the cofactor and you can find the minor. So a note here. It says, note that a cofactor Aij is simply the minor Aij multiplied by either 1 or what? -1, depending on whether I plus j is even or what? Odd. So it means if you have a 3 by 3 matrix, we can obtain the cofactor of any element by prefixing its minor with the sign obtained from the following checkerboard pattern. Because, every element, if you have a 3 by 3 matrix, what is this? This one means I is 1. So I is what? 2. I is 3. Here, j is 1. J is 2. J is what? 3. So in this position, you will see that if you have -1, I plus j, it's going to be -1, 1 plus 1, which is -1 to the power 2, which is going to be positive. So this position, the element here is always going to be positive. This one is going to be negative in terms of position, not the element itself. Why is it negative? Because I is 1, j is 2. So in terms of position, it's going to be negative. This is 3, so 3 plus 1 is even, so it means it's going to be positive. So this is how the signs alternate, depending on the position of the element. So this is helpful when you want to find the determinant of a 3 by 3 matrix or of any size. You can just apply that directly. So let's see some few examples. So look at this example now. This is example 3 or example 5. Here we calculated the determinant, so let's just go through it. So we want to find the determinant. So to find the determinant, all you need to do is you look at this one. In terms of position, this we know is going to be what? This is going to be okay. In terms of position, this itself is going to be plus. This is going to be minus. This is going to be plus. And this is going to be minus, right? Plus, minus, plus, minus, plus. Yes. So this is in terms of their position. So now we want to expand. We'll try to find the determinant. You expand along here. We are using row 1. We're expanding along row 1. So this is 2. And you can see in terms of position, 2 is positive. So we just take the 2 out. Then you multiply by what is left. I mean, what is left means now multiplying by the minor. Now you don't need the cofactor again, because the positioning has already taken care of the cofactor. Remember, the cofactor itself, Aij, is -1, I plus j m ij. So it depending on what is I plus j. If I plus j is even, then it's going to be positive. If I plus j is odd, it's going to be negative. So that is why we have these signs here. So in this case, for this element 2, we know I plus j is positive because I is 1, j is 1. So it's even. So that is why we have positive. So just take the 2 only. Then you close the first row and the first column. So what is left now is just this one. So you close this, what we do, close this. So we're left with 2, 4, 5, and 6. So that is why we have this determinant. Then we move. Here you can see the number here is 3. But in terms of position, I plus j is odd, because this means I is 1, j is 2. So it's odd. So that is why you have this -3 here. Okay. Then we close this, what do you call it? We close the first row and second column, and you will have this determinant left. All right. Okay. Now let's go to the next one, which is this one. So you see plus, right? It's plus. Why is it plus? It's plus because by this position, what you have is plus. But the element itself is minus. So you have plus minus 1, then multiplying by the what? The determinant of what is left. And then you just perform this. So this is 2. Then you find this determinant, this times this minus this, 2 times 6 minus 4 times 5. And here it will be minus 3, then 0 times 6 minus 4 times minus 2. And here plus minus is going to be minus. So you have this times this minus this. And we evaluate this. It gets minus 44. So this is the determinant. Okay. Now, let's look at this example 6. Example 6 is a little bit, we want to find the what? The determinants of this matrix. So, but this is 4 by 4. So to look for the determinant of 4 by 4, we can still make the same thing. In terms of position, we know that this is going to be what? This is going to be positive. This is going to be negative. This is positive. This is negative, right? Why? Because, why is this negative? Because this is first row and what? First row, fourth column. So it means minus 1, I plus j is going to be odd, right? So it's going to be minus. In terms of position, this is going to be negative, positive, negative, positive. And this will be positive, negative, positive, negative. Yep. This is going to be negative because this is, in this case, I is what? 1, 2, 3, 4. And j is 1. So this is going to be positive. This would be negative, positive. All right. Now, if you want to find the determinants, since this is 4 by 4 matrix, one trick is for you to use a column. You can do it anyway. You can use any row or any column. But to simplify things, we're going to use a column or a row where there are many zeros, just to simplify the computation. So if I look at this carefully, I think there are more zeros where in this column. I have 2 zeros in this column. Now, since I have 2 zeros in this column, I will use this column to find this determinant. So if we call this matrix A, then matrix determinant of A is, I will start from here. This is 0 plus. So I will just put 0, right? Then I will take what is left. So it means I'm supposed to have 0 multiplied by what is left. It means when I close this row, column, and I closed what? The first row. So we will have a determinant of 0 minus what? 2, then 4, right? Then minus what? So it will be 0 minus 2, 4, and then minus 3, 1, 2, and then 1, 0, and what? And 1. Okay. Now, remember we are coming down the column. So the next one is going to be -1. Then I'll multiply by what? -1. Why am I using minus? Because of this position, right? So now I'm going to close this. So what is left now? It's -2, 1, 1, then -3, 1, 2, then 1, 0, 1. Okay. Okay, then plus 0. This 0 now. So now I need to close this one. So this will still be -2, 1, 1. Now this one will come in. So this is 0, -2, 4. Yes. So finally, this will be 1, 0, 1. So note something. When we're taking the elements, we're not taking the positional signs, right? So like here, when I'm taking 1, 0, and what? 1, not minus, not with the positional signs, okay? Then finally now we have -2. So now I'm now in the last term. I'm using -2. But now look at it. Here, we have a minus from the position and we have a minus from the elements. So that will make the here to become what? +2. So let me put it this way, because it's going to be minus, then -2. So now we multiply by -2. So we're dealing with this element now. So we have to close. We have to close now the third row, the fourth row. Yeah, so we close the fourth row. And this will give us -2, 1, 1, 0, -2, 4, and then -3, 1, and 2. Okay. So now, if you look at the good thing is that what? All of these will go. This term will go, and this term will go. So that is why I chose the expansion by what? Column 3, so that it will reduce the computation. So here now what we have is just we have -1 multiplying by -2, 1, 1, -3, 1, 2, and 1, 0, 1. This is minus minus becomes +2. Then -2, 1, 1, 0, -2, 4, and then -3, 1, 2. All right. So now you are back to we're back to 3 by 3. So once you are back to 3 by 3, you have option. It's either you continue breaking this into smaller pieces, or you just go and use the what? The Saros method, which sometimes is faster and easier. So now let's use the Saros method for this one. So this is 3 by 3. So let's take this matrix now. This first one is -2, 1, 1, -3, 1, 2, 1, 0, 1. Then we can augment this with -2, -3, 1, 1, 1, 0, right? And then we will have Just go with this, and this. This. So it means this determinant will just be what? Here, let's do it this way. Don't forget that you have -1 here. So let's put the 1 here. Then multiply. The determinant of this will just be 0. We go this way, so this will be 0. Plus what? Plus 2. Then I'm going the main diagonals now. There is the blue one. -2, -2. So this is -2, right? Then minus. Then the green one, from the ground, I'm seeing -3 plus 0. Then plus what? Plus 1. I think so. Oh, right. Okay. It's what we have. Then plus 2. Okay. Now I need to find the determinant of this one as well. So this one here is this one. So let's write it here. -2, 1, 1, 0, -2, 4, -3, 1, 2. And then this will be -2, 0, -3, 1, -2, 1. We have this one. Okay, so here we see that these two are free. Okay. So here will be 3. Then so let's go now. The main diagonal, this is going to be 0. I can see a 0 in one of the main diagonal. And this is plus -12. And this is plus, is this a 2? Okay. So this is 8 minus the minor diagonal. We can see, can also see a 0. So we have 0 -8. And then plus 6. Okay, so this is what we have. So here is going to be minus. This and this will go. So this is 0, everything here. And this will be -3 plus 1, which is -2. So this will just be plus 2. Then plus 2 here. This is -8, -12 plus 8. So you have -4. All right. And this is -8 plus 2, which is -2. So this becomes plus 2. So this is just going to be -2 plus 2 multiplied by -2 again. So we're having -2 and what's -4. This is -6. Well, all right. So now this is how to find for any, even if it is 5 by 5, you can first of all reduce it, keep reducing it. But when you get to 3 by 3, then you can go ahead and use the Saros method. Now, let's talk about, again, determinant of matrices in triangular form. If you have matrices that are either in upper triangular, in triangular form simply means that you have a matrix whereby every element, for example, this is a triangular matrix, is in triangular form, because if you look at the main diagonal, right, this is the main diagonal, every element below the main diagonal, you see that they are what? They are zeros, okay? So this is an example. So you see all these elements are zeros. And in this case also, you see all the elements above the main diagonals are what? Are zeros. So this type of matrix, we call them matrix in triangular form. So what you can do in this type of matrix, if you want to find the determinant is simply you multiply the elements in the what? In the main diagonal, right? So let me just solve this one. So if you want to find the determinant of this matrix A, so here, to find the determinant of A of this matrix, so the determinant of A is just going to be 2 times -2 times 6 times -5. And this is going to be 4. This minus and this minus will go. So this is just 4 times 6 times 5, right? And what is this? This is just going to be 20 times 6, which is 120. Similarly here, this is our main diagonal. Every element above the main diagonal is 0. So if I want to find the determinant of B, you just need to multiply 3 times 3 times -2 times 2. And this will just be 9 times -4, which is -36. Okay, so this is how to find the determinant of a triangular form. You don't need to worry. Just multiply the elements in the main diagonal. But this only works if it's a triangular matrix. Okay, so for example, if you have maybe another element here, maybe 2, then you cannot use this